Hi there, welcome to the RetroDesk. I'm Matt Heffernan. This is the third lesson in my newest tutorial series for people to learn programming using the Python language. This tutorial is for absolute beginners, no experience necessary. But if you haven't watched the earlier lessons, you want to stop right here and go watch them from the beginning if you have never programmed before. In the last lesson, we expanded on the foundational topics from the first lesson, learning how to take text input from the user and parse it into values of different types. We learned that Python uses classes for types and that objects of a class can have attribute values and methods that can be called on them. We learned how if-else statements worked and how to use Boolean true-false values and expressions to determine what code is going to run. Finally, we learned the names of all the different built-in classes, including float for floating point numbers. But now it's time to learn about another important built-in class. If you need to have a collection of values in a specific order, Python lets you put them in a list, which is pretty much what it sounds like. It's a sequence of objects that can have any class, kind of like how strings are sequences of characters. You could easily express a string as a list of characters, like this. My string list equals bracket, and then each letter in quotes, quote H, quote, comma, and so on with E, L, L, O, and an exclamation point, and then a close bracket. The square brackets let Python know that this is a list, and the elements of the list will be separated by commas. Let's go to Thani and try this in the shell. Let's type in the assignments we saw on that last slide. First, we create a string. My string equals, quote, hello, and close the quote. And then we create a list. My string list equals bracket H, and comma E, comma L, L, O, exclamation point, and close the bracket. If we use the type function, we can confirm that my string is an object of the str class, and that my string list is an object of the list class. But we can see that there's more to a list than just the list. There are more objects inside it. To get an element of a list, you use brackets again, but this time right after the name of the list variable. Inside the bracket, you need the index of the element, which will be an integer from 0 to 1 less than the length of the list. This means that Python list indexes are 0-based, which can be a bit confusing. My string list has 6 elements, so the indexes go from 0 to 5. Let's go back to the shell to see how this works. So we get the first element with my string list, bracket 0, close bracket, which we can see is a capital H. If we look at the type of this element, we can see that it's a string. Python doesn't have a type for just a character like some languages. It just has strings that have a length of 1. We'll see the same thing for the last element of the list, index 5. That's just a string with only an exclamation point. Another feature of Python is that strings already work a lot like lists, and we can use the same bracket syntax to get individual characters in a string. So my string, bracket 0, will also be a capital H. And if you look at the type, it's still a string, just a 1-character substring of a larger string. So we really don't need lists to be composed of just single-character strings. We just use multi-character strings like we have been so far. Lists are better for things like numbers, so we can define one in the same way. My number list equals bracket 2, 4, 6, 8, close bracket. And then we can look at individual elements. Index 1 will be the second element. So my number list 1 will get us the value 4, as that's the second number in our list. If we look at the type of the whole list, it's still just the list class, no different than our string list. But when we look at the type of an element, we see it's an object of the int class, an integer. Like all classes, there is a list constructor, which acts like a built-in function called list. The argument to this constructor needs to be something that has multiple elements like a list, such as a string. We could have saved ourselves a lot of typing by just using the list constructor to create my string list and passing in the string variable we already had. There are a bunch of methods you can call on a list to get information about it or change it in some way. Say you wanted to find the O in hello. We could just call the index method, which returns the index of the first element that matches the argument you pass. Let's try it out in the shell. Just to test it out, let's recreate my string list using the list constructor. And we pass in my string. Now we can see it still has the same value when we typed it out the hard way. If we call my string list dot index parens quote O, we get the return value 4, which means it's the fifth element of the list. If we try to find the first little l, we get 2, meaning the third element is the first one that's a little l. The fourth element is also a little l, but we didn't specify where to start looking. So the index method will start from the beginning of the list at index 0 and search from there. If we try to find an element that doesn't exist, like x, we get an error. So that's something we need to handle. We'll see how to do that later. There are a bunch of other methods we can look at another time, but there is a built-in function that is very useful for lists. To get the length of any object that's a sequence of elements, including strings and lists, you can pass it to the len function, which will return the number of elements in it. Let's give that a try in the shell. We can use the len function with strings, and we see that the length of my string is 6, which is no surprise. We could pass in a literal string too, like len quote hello Python exclamation point, and get that length. It works the same for lists, and we can confirm that my string list also has 6 elements, and that my number list has 4 elements. Or we can pass in a new literal list like len 1, 2, 3 and see that we know how to count. But what if we want to do something with each element of a list? To do that, we need a for loop, which lets you execute the same code block for every element in a collection, like a list or string. We start with the keyword for, then we name a new variable that we are going to use in our loop code for each element. So let's call it E for element. Then we need the in keyword, followed by the collection, and finally a colon to indicate that the next code block needs to be indented. And then we can have our code, and here we'll just print each element one at a time. Let's try writing a program like this in Thani. Okay, let's declare our old friend myNumberList again with 2, 4, 6, 8. Now we want a for loop, so we start the next line with 4, and then we'll call our element variable num for number, and then the in keyword, and finally myNumberList, and a colon. Thani nicely indents the next line for us automatically, and we'll go ahead and print the number element. And that's it. So let's save our program as loop.py and run it. Now we can see in the shell that our program printed each element on its own line. But that's a lot to print out, and what if we only want to see numbers over 5? For that, we can put an if statement inside the for loop. So now we insert a new line at the beginning of the for loop block and put in if num is greater than 5, colon, and then we indent the print statement in further. This means that instead of printing for every iteration of the loop, we are only printing when the number is greater than 5. This is one of the most important parts of writing Python code, making sure you have the right amount of indentation for each line. In the for loop, we will compare each element to 5, but only when that comparison has a true result do we do the print. because that is indented further than the if statement. Now at the bottom, we'll print all done, but this time without any indentation. This means that it will happen after the loop is done running. We're not in the for loop code block anymore. Let's go ahead and run this again. Okay, now we see that only 6 and 8 are printed, and then we get the all done at the end. So now we see how to have a for loop go over a whole list and then decide element by element what it wants to do with it. But what if we already know that we want to skip the first 2 elements? As you might suspect, computers are really good at making sequences of numbers. Python has another class that's similar to list, but it's just for integers in numerical order. If we wanted to just get the numbers 2 and 3, which happen to be indexes of the numbers in the list that we just printed, we could use the range class. If we call the constructor, we can pass 2 as the first argument, saying that this range starts with 2, and then 4, which means that this range ends before reaching the value of 4, so we should stop with 3. The range constructor also has a third argument for step value, meaning that the numbers can jump by a fixed amount, like in our original myNumberList. Instead of listing out all the numbers in code, we could just say range 292. So it will start with 2, then jump to 4, then 6, and finally 8. But it won't go to 10 because that's greater than 9. You could also just pass 10 as the second argument, as we know the range will still get cut off after 8. So we could rewrite our program to just use ranges instead of lists. Let's go back and do that. First, let's replace our list declaration with a range declaration. We'll say range 292, and that should get us the same 2468. Then in the for loop, instead of using the if statement to only print out the last 2 elements, we can have the for loop go over the range of indexes we want, starting with the third one. Remember, indexes are 0-based, so for the third and fourth elements, we want indexes 2 and 3. This means we can have the for loop go over the range 2 to 4. We don't need the third argument in this range because we are using the default step of 1. We also don't need this if statement anymore. So let's delete that, and then we can get rid of one level of indentation for the print line. But now we don't want to print the index here. We want the element from myNumberList at this index. To get rid of some confusion, let's rename the loop variable from num to I for index. Then we will get that number we want by indexing into myNumberList with our new index variable. So now we print myNumberList I, and we're done. Let's run it again. We can see that we now have the same results with less code. At this point, you may be getting a bit confused with how the numbering works for indexes and ranges. Let's review that a bit. A list can be a sequence of anything in any order. A string is like a list of characters, and you can treat one like that in many ways. Lists and strings are both index collections, and the index of the first element is 0. You can get the length of a collection with the len function, and the return value of that will be 1 higher than the highest index. So a list of 5 elements will have a length of 5. But the 5th element will be at index 4 because the first element is always at index 0. A range is another collection, but it can only be integers in a fixed regular numerical order. They can have a step value so that each number can be 2 or more higher than the last. The range constructor has 3 arguments, all of them integers. The first one is the number to start with. The second is the number to end before. The optional third argument is the step value, which is 1 by default. You can do something to each element of a collection with a for loop, which will run a code block once for each element. So let's try a little pop quiz back at the shell. Okay, let's define a string called name, and we'll set it to Matthew. Now what will we get if we call len name? That's right, 7, because Matthew has 7 letters. So what if we try to get index 1 of that string with name bracket 1? That's right, it's an A, the second letter of the string. So what if we want a list of letters instead of the string? We can pass name to a list constructor. So let's say letters equals list name. Okay, now we have a list. Will the same things apply? Let's see. Then letters, yep, it's 7. And letters 1, yep, also an A. But what if we want to look at the whole value of name? We get the whole string together. But if we look at the value of letters, we see the letters separated into elements of a list. Okay, let's create a list of numbers. We'll call it numbers and assign it 8, 6, 7, 5, 3, 0, 9. How long is this one? Yep, it's also 7, but this time it's 7 numbers and not 7 letters. What we get for index 0. So numbers bracket 0 gets us, that's right, 8, because that's the first element of the list. But what's the index of the value 0 in the list? Let's try the index method. Numbers.index parens 0. What should we expect? Yes, it's 5, because 0 is the 6th number in the list, so it will be at index 5. We can verify this by doing numbers bracket 5, and there we see 0 again. The range constructor can also be confusing, but thankfully the list constructor can help show you what it does. Say you redefine numbers as range 3, 10. What numbers are you actually going to get? Well, if you try checking with the shell, numbers is still just defined as that range, and it doesn't tell you what values it would have. If you pass a range into the list constructor, it will expand it into a list that you see in the shell. So list parens numbers shows us that this range gives us the numbers 3, 4, 5, 6, 7, 8, and 9, but not 10. Remember, a range stops before you reach the number in the second argument. Now, what if we add a third argument to give it a step value? Let's start with the list constructor right off the bat and type in list parens range parens 3, 10, 3. Close with 2 parens. Remember, we need to close with 2 parens for both the range and the list constructors. So what should we expect here? Yes, it counts by 3s, 3, 6, and 9. So if you need to come up with a range, this is a good way to make sure you are getting the sequence you want. So now that we have a better handle on how to create lists and ranges and access elements in them, let's try to make our code even simpler. In our program, we are using a range to define a set of indexes to use in a for loop, and then using that index with the original range to get the values we want. But in Python, we don't need to do all that. We can slice collections like lists and ranges, and even strings, and get just part of that collection. When we just put a single index value inside square brackets after a list variable name, we get just that one element at that index. But say we want that element and the next two. We can get a slice of that list using a colon after the first index, and then one past the index of the last element we want, just like in a range. But we can also get a slice from one element through the end of the list by omitting the second index, and just have the closing bracket right after the colon. Let's give this a try in the shell. Just like in the slide, we'll define a list called fib and assign it 1, 1, 2, 3, 5, 8, 13, 21. Now, if we want to start with the 5th element and end with the 7th, we will slice fib from index 4 to index 7. And we can see that this results in the list 5, 8, 13. And if we just slice from index 4 to the end, we get the 21 as well. Slicing works with other collections, of course, including strings. If we say hi equals hello Python, we can slice out just the hello by going from index 0 to 5. One shortcut Python gives you for slices that start with index 0 is that you can just leave the 0 out and start with a colon. So hi bracket colon 5 will give you the first 5 characters. Same goes for lists. Fib bracket colon 5 gives us the first 5 numbers. And of course, this works for ranges as well. So let's just go right to our program up here and simplify our loop even further. Rather than defining another range to index into that first range, we'll just slice that first range. So we'll delete the second range and put in the slice my number list bracket 2 colon close bracket. We won't bother putting in the ending index because we just want to get the rest of the list. Now we aren't getting indexes anymore, so we'll rename I back to num. And since we're getting the numbers we want again, we can also revert the next line back to just printing num. Let's run it again. And there we go. This code is a lot simpler and tighter now. Now before I go, I mentioned that a list could be changed. This is different from a string, which can be sliced or reassigned, but an actual string object cannot change. You just have to keep creating new strings to get something different. Like when you concatenate a couple of strings, you don't change either of them, you create a new one. You can do the same thing with lists too. If you add one list to another, you get a new long list with all of the elements from both lists. But instead of creating a new list, an old one can keep on going as long as you need it, and you can add and remove elements however you want. Instead of concatenating, you can use the list method extend, and it will extend the list to contain the elements of another list. Now, instead of returning a new list, that first list is modified. We can also just add a single element to the end with the append method. Let's go back to the shell and see better how these work. So we already have the list named fib, but let's extend it. We can call the extend method on it and pass it a literal list with some more numbers. 34, 55, 89. Close the bracket, close the parens. Now if we take a look at fib again, we can see that it now has these 3 new elements at the end. Then we can add one more at the end with the append method and pass it 144. A quick check, and now fib is really going places. But what if we feel we've gone too far? Lists have another method called pop, which pops an element off a list. To be nice, it also returns the value it popped off. So if we pop fib, we get that 144 returned to us, and when we look at fib again, it's back to where it was before we appended it. We can pop out other elements by passing an index to pop. So calling fib.pop parens 0 will take off that extra 1, which I don't think we really needed. Or you could pop out that 5, which is now at index 3. That 5 got a lot of play already. It's done now. There's a lot more you can do with lists and other loops besides for loops, but for now we're done. We'll get to those in another lesson. I want to thank you for continuing to watch this series, and I can't wait for you to see the next lesson. If you aren't already subscribed to my channel, make sure you do that now and click the bell to be notified when the next video comes out. If you want to support my channel more directly, you could become a member here on YouTube or join our Patreon community, like the people you see here. Members and patrons get to see all my videos before they are released ad-free, along with other nice little perks. Thanks for watching, and I'll see you again soon. Bye-bye.